Hello viewer, this oscilloscope has gone out of order and before use it needs repairing. Today I will explain you and also demonstrate how to repair this oscilloscope. The internal cleaning of the oscilloscope should be done regularly to avoid the accumulation of the dust. A special attention should be paid to high voltage section and the connectors. Any conductive particle in this region may result the arcing. The cleaning of rotatory band switches and the lever become necessary after a period of 1 year. Ball points of the rotatory switches require lubrication. If lubricating part collect dust, clean it by recommended brush. When there is a trouble in band switch contact, the contact should be cleaned by acetone or carbon tetrachloride. To get the smooth movement of levers, oil them properly. Clean the lever switches using carbon tetrachloride or acetone to avoid the contact problem. It has been noticed that after long use of equipment, heat is generated inside it. That may develop several faults, such as poor connection, broken or damaged leads, deterioration in components, overheated resistors generally show a charred look, as in this CRO. A burnt out or a heavily loaded transformer gives out a foul smell. It does not mean that the symptoms of visual inspection are only the region of defect in the equipment. The fault may be anywhere in the circuit, and you will be able to localize these faults only by way of corrective maintenance. To localize the problem in CRO, you may divide your maintenance in two parts. First, the symptoms available in your CRO screen. The second, the variation in brightness, focus, or intensity, mainly because of the power supply problem. All these problems are interrelated. Therefore, to repair any oscilloscope, one has to understand at least the working principle of a CRO. First, let us see the block diagram of the CRO. It is the block diagram of an oscilloscope, and here it is power supply section, it is horizontal section, it is vertical section, and this is a display section. Power supply, it is horizontal section, it is vertical section. The main supply, first step down through step down transformer, and voltage regulated power supply is fed to all sections of an oscilloscope for the functioning of circuits. The horizontal section generates the sawtooth and fed to the CRT to generate the beam, and the input to CRO is fed to the vertical section that goes to Y plates of CRT to make wave shape. To take up corrective maintenance, it is advised that first one should consult the service manual of the equipment. During use of an oscilloscope, often you face the problem of mains fuse blowing, pilot lamp does not glowing, pilot lamp glowing but no trace on CRT screen, improper functioning of intensity control, etc. In general, all these problems are created by the power supply section of an oscilloscope, and to repair a power supply is a challenge for a maintenance engineer. The power supply section of an oscilloscope provides different voltages required by different stages. To minimize the variation of either mains voltage or load, these supply voltages are regulated as and where required. Power supply section of this oscilloscope is here. And the power supply section of this oscilloscope is here. The power supply section of this oscilloscope. If you understand the working principle of a voltage regulated power supply, the maintenance becomes easier. The circuit diagram of this oscilloscope is here in this figure. Here in this circuit diagram, this is the step down mains transformer. These are the points connected to AC mains, and it is mains fuse, and this is the step down transformer, provides the voltage to this bridge rectifier, and the rectified voltage is here. This capacitor filters the ripple, and the unregulated voltage is available at this point. This is the voltage regulator. Here in this diagram, the reference voltage is maintained here via this way. This is the comparator, in which the unregulated voltage is provided at this point, and the feedback voltage is provided at the base. This is the correction amplifier, and this transistor TS402 is series regulator, and these are the load sensor resistor. Load is sensed by these resistances and feedback to the circuit in this way, and the regulated output is available at this point. The DC voltage available at this point is fed to the oscillator section, where this DC voltage is converted into high frequency voltage, are available at various points through this transformer. Since the frequency of the oscillator is higher, to rectify these voltages need a smaller capacitor, and multi outputs have been taken from this transformer. Sometimes mains transformer also creates such problem. This is the mains fuse, which is blowing again and again, and the reason is any of the rectifier diode shorted, or the filter capacitor may also become shorted. Another reason for this problem may be either primary or secondary binding of this mains transformer. Remove faulty diode and check by multimeter. The faulty diode will show short circuited. Same is the case with filter capacitor. First, remove the mains connection and search the rectifier diode, which is here, and its filter capacitor is here. Check the short circuiting using multimeter. One of the diode of this bridge rectifier is showing short circuiting, which is the reason of mains fuse blowing. You have seen using multimeter that one of the diode of this bridge rectifier is short. Replace it using a good soldering iron. You have removed the suspected bridge rectifier. Confirm it again using good multimeter. If the pilot lamp of this defective oscilloscope is not glowing, check the following suspected component: defective lamp, fuse blown or mains lead open, defective main switch, open primary binding of main transformer, and these components are here in this oscilloscope. Pilot lamp, fuse, defective main switch. This is the main transformer. The primary binding is here, which is connected with the main switch. See in this figure, the main switch, fuse and the primary binding of the transformer are in series. If the symptom of not glowing the pilot lamp may be reason due to open main switch or fuse or open primary binding. Therefore, check one by one. Ensure the CRO is not connected with the mains. Then first remove the fuse. Then check the continuity of the fuse. It shows fuse is open, and that is the reason of not glowing pilot lamp. Put the new fuse. After putting the fuse, check the continuity in mains lead, and still it is open, means either main switch or the transformer primary binding is open. Check it. Main switch. Check the primary binding continuity. Which is okay. For not glowing of pilot lamp, we have checked the main switch, the mains fuse and the transformer. All these are okay. It means now the suspected part is the mains lead. Replace it.